We are going to discuss FortiGate. There are two modules basically for this particular firewall, which cover the tag level, uh, tag level content. We might not be able to go into too many details, but at least from the intermediate point of view, not just beginners. So we'll try to cover all the things that you guys uh, would need or would help you to get the hands dirty on the product so that you can build the rest of the stuff on top of it. Uh, all right, so give me heads up if you're good to start.
Yes, I guess we can start it.
All right, Fazan Gulzar is raising, and please go ahead if you have any question. Mm. No question? Okay. So before we actually start the firewall, the first and foremost thing that's important to mention is why do we need the network security? You guys have any idea about that? Yeah. So for your information, this session is quite, uh, I mean, there'll be a lot of debates going on. That's what I like basically. Uh, it will be sort of collaborative knowledge sharing, not just me throwing this stuff on you guys, right? There are a lot of people here who know much more than me, and I'm sort of seeking inspiration from these people. So they're also here. So it is quite important that we keep the discussions going on. Yes, Buran, you want to ask anything?
No, I want to answer the question that you asked.
Mhm.
Why do we need firewalls? Because of the reason that any network is vulnerable to any intrusion, and to keep a network secure and safe, and all the devices, all the resources keep to be kept safe from these intrusions, we need firewalls, and we depend on it because there's a lot of confidential data. As in today's world, the internet and our lives revolve around internet, so we need to keep our data safe, so which is what the firewall helps us to do.
Yeah, quite detailed. Anybody else? All right. Thank you, Burhan. So, uh, there are a couple of things where I would say that yes, we do need network security, but then the perspective lies behind the data, right? The data is quite important. The data is sensitive, and data has to be confidential. And the reason for that is uh, if Naseeb talks at an individual level, I don't need a firewall at my home because I'm not doing any bigger projects at home, right? I'm not a big player in the market,
Yeah,
right?
right.
I don't have too many research or documentations in the DBs databases. So have you want to say something? Okay, that's Samir. Samir, you want to say something?
No, no, no. Please go ahead.
Yeah. So I was trying to say that uh, the frame of reference will always matter because for an individual who doesn't have a lot of stuff to do, right? He might say that, okay, it's probably not important. But for the bigger companies, for the bigger firms, for the bigger MSSPs, right? Uh, the companies which have projects going on, they have research going on. For example, if I talk about one of the aerospace company, uh, who is just trying to manufacture good quality tires and they're just researching on the products, right? They have documentation, the databases, and they want to get very good at their quality. And not just this, they also want to uh, supersede whatever is actually going in the market. So they want to put something really on the table which is far better than anybody else. And now that all that data, which is actually pertaining to their researches, all that documentation, that needs to be secured. That's the whole point here, right? So the frame of reference is quite important. Now, let's say, for example, if they don't talk about their network security, right? They don't have a firewall there. They don't have any of the endpoint security there. They don't run antiviruses. Now, all of a sudden, an employee in their company got ransomware attack, right? So it's like your whole database actually, or your whole PC, which actually contained all those sensitive credentials of the databases where you store the documentations, right? That got encrypted, and now that particular person is basically asking you for ransom money, right? And it's at that point the whole progress of your company is at the toll, right? Uh, Now let's say, for example, you had completed that particular project 80% and that got stolen by any attacker because you didn't ponder over the network security things, right? So what would happen actually? That particular research, that documentation will be set for bidding, right? Uh, there are a lot of markets where there are bigger competitors. They come and they basically buy all that stuff from the other people, right? If Nasir is an attacker, he's just going to steal anything from one company, then going to sell it to his competitor, and that way, the other company, which is a competitor, right? He gets an edge. He gets a progress of 80% without doing anything, right? So it's sort of a data rivalry. It's sort of research rivalry. It is sort of the market competition, at least for all the product-based companies. So that's where the key role actually comes regarding the network security, and not just this, right? There is one more thing which is quite important. Whenever you, or say for example, if Samir opens a company and then Samir says that I claim myself to be a company, right? Then to claim that you actually are a company, you basically have to follow set of regulations, rules, protocols, right? And that particular rules, protocols, or whatever you call it, it's called ISO, right? You have to be ISO certified, and you'll be asked, for example, if Samir says that, okay, a lot of money, I want to invest it, I want to open a hospital, right? The first and foremost thing that people are going to check is what are you doing with the data of the people, right? If
Yeah.
there's a patient that comes to you, he writes his name, he writes his residence, he might write his phone number. What's actually going on with his data, right? That's why you say that, okay, I don't just uh, misuse that particular data. I have this particular way of protecting this data. And how do I protect? How do I make sure that nobody has access to this particular sensitive data? I do what? I bring in the concept of network security, right? Because say for example, if let's just talk about this particular hospital, right? What would basically happen is that if a particular guy is sharing his details on a particular ticket that you basically open in the OPD, right? He can
Hmm.
sell it. He can sell it to other competitors in the market. There are a lot of hospitals now,
Yeah,
right?
right.
And then you get all those messages that we're doing these tests for free. That's a scam, right?
Hmm.
So that's how they actually play with this with the data. So the whole point is the first thing, the frame of reference, what we are talking about. We're talking about the data and how sensitive is it to you being a company, right? And that's why the need of protection comes. And that's why you say that I need to secure it. And if you want to secure it, you need tools and you need products to secure your data. And that's the whole point of need of security these days, right? There are bigger players in the market. There is NASA, Tesla, a lot of people. They're doing a lot of research on a lot of things, right? Nobody will ever disclose their code, their formulas to the other people because then they're going to do what? They'll just surpass them, right? So that's the whole point of network security. And that is the key point. When you grow, then there are a lot of rivalries that you start actually facing, and you say that okay, now that the attacks are basically shown up, let me just try to make myself quite confidential, make myself not too exposed so that my presence will be exploited. That's the whole point. Because if you run on the internet, there are a lot of other people. If they catch you, if they know your public IP, they're going to attack you. What are the attacks? We are going to see in the upcoming sessions. So this was the whole point. Now the whole market, whole IT was growing. Uh, the whole technology was growing, right? And then
Mhm.
what people say was that they said, okay, now we need network security. Now, the first thing they actually started with was packet filtering and IP tables. So what they did basically was there were a couple of architectures they actually started to follow in the very beginning. All right. So the first thing that they did was, say for example, this is a bigger company where one of the CEO is actually working. It's his PC, right? He's connected on a Cisco switch. It's a Cisco switch here, right? And then to this Cisco switch, there is this router connected. It's a Cisco router by the way. And then this line basically is connected to the internet, right? This is internet. So this particular man is actually making transactions, right? Emails, uh, is sharing data and rest of the stuff, right? He's doing a lot of things. So the first thing after realizing that there is need of the network security was that they started saying that okay, there's a way of doing it on the router. We don't have any other tool to do it to start with. So let's start with doing the ACLs on router. So
Okay.
what's an ACL and how many types of
Access.
ACLs do we have on the router? Yeah,
Um,
anyone?
I guess standard extended, right?
Correct, yeah. So what do we achieve? What's the business use case for the ACLs?
We can filter the traffic on the base of IP addresses.
Correct. So there is standard and there is extended, right? You came
Mhm.
with a standard RFC first, and then you said that, okay, I can sort of say that anything that goes out, anything that comes in, I'm going to filter that based on the ACL statements that I basically write, right?
Yeah.
So I'm going to write the statement saying that, okay, there's a one known IP that I want to go outside my company. There's one known IP that I want to come inside my company. Because there are a lot of people trying to reach me now. My PC cannot handle too many requests. It's sort of unauthorized people trying to call me, right? When I'm
Mhm.
roaming on the internet, right? When somebody puts his phone number on Facebook, what happens? When someone accidentally puts your phone number on Snapdeal or maybe O- OLX.in, what happens? You
It's
start getting the
bombarded with
calls.
calls. Yes.
Yeah. So that's what happens. So I want to be less known to the people now. So the
Mm.
thing that I basically do here is I say that okay, anything that has to reach me has to pass one thing now. And what's that? That's an ACL defined on the router. And how do you define that? You define the statements, right? There are
Yes.
statements that you basically define the router. And the first thing that you can do it via is standard access list, where you basically put the IP addresses only, right? You define statement one, you define statement two, you define statement three, and then you have an implicit statement which denies everything, right?
Hmm.
So this was the whole point of using this standard ACLs. And then you say that, okay, I want to do this based on the ports as well. So you came up with this extended
Extended.
ACLs,
Hmm.
right? So you have IPs plus ports
And protocols.
plus protocols, right? So
Mhm.
similar concept, you will be writing statement one, statement two, statement three, and four, and eventually there will be one statement that will deny
Mhm.
everything. Now anything that has to come in has to find a match. And how does it find a match? It finds match in the top-down approach. It's going to look for one, okay, does it match me? The answer is
Hmm.
no. It
Top to
goes
bottom.
down, correct. And then it goes down. If it doesn't match all those three statements that have been manually put there, that have been written there, it's going to hit what? Denial, and it just becomes the router is actually going to drop it. Right. So
Hmm.
that is the whole concept of network security using the ACLs.
Yeah.
Right. Now coming to the extended ones, again, if someone is trying to reach out to you, he has a particular protocol that he actually follows, be it any of the application level protocols, and
Hmm.
then he has ports as well, right?
Yeah.
He comes up with some of the IP addresses. Again, he's going to look for a match in the top-down approach, and eventually he lands on this page. If he is not able to match any of the four statements on top, he lands on this particular statement and then gets dropped, right?
Hmm.
So all the statements that I have written here is something that I know. I know that they're actually known to me, and I know they should actually come in and or come out, go out of this particular company, right? So this is uh, how people used to do it in the beginning, but then there was one thing. So the whole thing is, what's a router? When you blow up a router, right? What is the primary job of the router?
Connected to different networks, we can say.
Exactly. So it basically routes to networks, right? And how does router route a network? What happens if there is a particular let's say this CEO was trying to reach out to Facebook. He wanted to see what exactly is happening on Facebook, or maybe try to see something related to the human resources. Like what CEOs basically do is they try to see where he can find a lot of people so that he can advertise the things. And now that a lot of teens are actually wasting their time on Facebook, right? He wants to sell them anything, and then he's going to access Facebook and sort of make a strategy then how he can basically pull in a lot of business from Facebook by doing advertisements and rest of the things. So what he will do is, let's say his IP is 192.168.1.2. He's trying to reach out to facebook.com, right? The traffic is going to hit the router. The router is also natting the traffic, right? What will happen? How will router route the traffic? It's a basic question to everyone.
Yeah, it will check the routing table as well if it has the entry. And actually, router it reads the IP header and consult the routing table, I would say, and forward
Correct.
the packet to the appropriate next hop.
Yeah, I see we only have Sameer taking part in the discussions. Anyone else?
Yeah, I think it when packet is received by the router, it is going to look for the destination IP address of the packet, and then uh, at the same time, it's going to look the routing table within the
Hmm.
router and will for the traffic based on that IP address.
Okay. And how does it do that?
Uh,
So uh,
mm.
maybe let's keep it for the other people, Raju. Uh, anyone else, guys? Guys, don't be shy. It's an open platform. Come on. All right. So I'll tell you how router basically does the route lookup, and this is quite important. You're going to keep this with you forever because
Mhm.
FortiGate is also a full-blown router. So the first and foremost thing the router basically does is it's going to pick up the destination IP address, right? And then look for the highest prefix match,
Yeah,
right?
longest prefix, yes.
If this matches to any of the entries in the routing table, it's going to use that particular entry. And then on top of it, if there are two entries which are matching with the highest prefix match, right? Then it's going to consider the admin distance, right? If there is admin distance also making a tie, then the tie breaks using the priority of a particular route, right?
Mm-hmm.
And if you're talking about the dynamic routing protocols, then there is one thing that's called as metric,
Yeah.
which will actually break the tie, right? So this is quite important. So this is how the traffic is actually going to flow out of this particular router. Now, the whole point is this router was there in that particular company for the purpose of routing and not for the purpose of securing the traffic, right? So what you
Right.
have done is if there was this router, it has constraints, it has resources, right? It has CPU and plus it has what? It has memory, right? What's memory, by the way? It's a working table of a particular machine, right? Its working table was to take care of the routing things. Now that what you're doing is you're just, if this is that particular routing table, I call this memory or I call it RAM. You're just putting other stuff on this one. It's not just routing now. It's also security part, right? So what will happen? This router will have too much to handle. So its resources might come into the equation if it's not a very higher range router. So the CPU plus memory, it's what? It's always limited. And the primary purpose of router was just routing. Now that you have put on the different things on this particular router, this is going to burden it somehow, right? So then
Right.
people started thinking that, okay, if there's an internet router, whenever we talk about the internet router, these are the routers which are taking part in the internet routing. And on internet, there are lakhs of routes. That's very important. And to route and to process those lakhs of routes is not an easy job, right? If you have a home router and you start going ahead running BGP on it, or just bring a small router, a very basic one, and then say that, okay, I'm going to use it for BGP. You know what will happen? It will not be able to take that load, right? So
Right.
the primary purpose here might come into the question when you are just overburdening this particular machine with a different thing, which is actually not its purpose. So what we started thinking was we started thinking that, okay, let's try to bring in something new. So they came up with the different architecture now, right? They said, okay, this is a CEO now, right? And then what happens is he is connected to one of the Cisco switches. And then there is this router, right? And in front of the router, what I'm going to do is I'm going to put a firewall. There are some of the architecture while you see firewall here and then router, or router first and then firewall, right? There are differences as well. We're going to see that as well, right? So this is a very basic firewall. It's a packet filter, right?
Mm-hmm.
What it does is it has IP tables. And IP tables is what? It's nothing but an ACL, right? So we are sort of creating a firewall rule now. We're sort of creating rules for the traffic to go out of this company and to come inside this company. But the only purpose here is that we're using a dedicated device for this purpose and not basically overburdening the router for this case, right?
Right.
So this was the concept of IP tables. IP tables, what IP tables would actually have is they will have one rule, a similar concept here as well, a similar type of architecture, while you will be having statements 1, 2, 3, 4, and a implicit deny, right?
Mm-hmm.
The first rule will say that, okay, there is 192.168.1.1, right, which actually got natted at this particular router, so it will be a different IP now. Let's say that it's 202.67. What's it? Uh, 202.67.220.220. Trying to go to Facebook, right? And it will be allowed.
Okay.
And then someone else, maybe a different IP, maybe same public IP, trying to go to gmail.com, that will also be allowed. Some different IP trying to go to hotmail.com, that will be allowed. And something else going to linkedin.com, that will be allowed, right? So you wanted to take care of all these things with the help of IP tables. right? And the whole concept of bringing in IP tables and replacing the routers with the access list with them was to not bring the performance of the routers into question. That was the whole point. Now, here's the thing. What's wrong with the IP tables now? Right? Let me bring in the correct architecture for this one. So this is CEO of the company. He's connected to one of the Cisco switches, and this Cisco switch has this IP table connected here, and then this IP table basically is connected to a router, right? Or what you can do is, let me just try to remove it. I'm going to connect this particular, so this is my IP table, or you call it packet filter, and I call this one as my ISP router, right? And then this particular router is going to go to the internet. See what happens here. My CO has an IP address of 192.168.1.1. I have done sort of a network segmentation on this particular Cisco switch. And when I say segmentation, I have done segmentation on a layer 2 device. It's a layer 2 device, it's a switch. And when you want to segment anything at layer 2, you basically do it with the help of VLANs. I have created VLANs on this one. And based on that, I have given a subnet of VLAN 10 to this particular guy, right? So I have VLAN 10 configured here, right?
Right.
And now that the traffic is getting tagged, right? This has to be a trunk link,
Yep.
right? So what I will do is I will make sure that when the traffic reaches to this particular L2 device, it will be handed over to what? To the IP table, which is nothing but the packet filter, right? It's going to say whether you want to allow it or deny it. And let's say in our case, it's going to allow it, right? The
Hmm.
traffic will be routed back now on the router, and router is going to do the route lookup. Again, the similar concept, similar theory here. It's going to look for the highest prefix match, then the admin distance, priority, metric, and eventually it's going to NAT it because it comes with a
Right.
private IP. It's going to NAT it, right? And when it NATs it, it means it's making it what?
Public.
It's making it public IP. It's basically translating the private IP into a public IP so that it will be known on
Top
the
secure.
internet.
Yep.
Correct. To be routable on the internet, right? So that's what basically happens here. Now here the thing is when we're basically looking into these details. Let's say I was trying to open what? CEO was trying to open
Facebook.
Facebook.com, right? The DNS configured on this machine, or forget about the DNS. I don't want to discuss the packet flow. You guys will get confused. See, I'm trying to open the Facebook page, right? It's an HTTPS request. It's an https://facebook.com that he has actually kept in the browser, right? If I come here and I say HTTPS, there's a data that actually flows back from the Facebook servers into my PC, right?
Yeah. Right.
And that's something that I want to discuss now. So if I come here, I try to make a connection with the facebook.com, right? And facebook.com basically shared a stream of data with me, and that's what I'm basically seeing on my screen. And that's what actually is happening with the CEO here, right? When he is opening facebook.com for the first time in his PC, what will happen? Anyone can discuss the packet flow now?
Can you please repeat? I lost it.
Yeah. Uh, Simi, let's keep it for the other guys as well,
Okay,
because
no
I
problem.
see everyone's quite muted. Not sure why. Guys, please go ahead. It's an interactive session. I want you guys to take part. Don't
Someone
be
in the
shy.
someone in the chat typed SSL handshake. I think before SSL handshake there will be TCP handshake. Okay, let's wait for this.
Come on. If you guys don't respond, I will pick one randomly. R21NTUCS1277. Please unmute yourself and say what will happen here.
So we'll look for the DNS cache first.
Okay. And so you're already there. So it's going to look for the DNS cache. And now that we are saying that he's trying to do it for the very first time, what will happen now? There is nothing in the DNS cache. So Fazan, if you're still speaking, you're on mute. Guys, don't type, unmute yourself and answer. I'll have to cut all these things from this video later on.
I just have one query. Can I say something?
Yeah, go ahead.
Uh, First of all, thanks for this opportunity. You guys are sharing this wonderful knowledge. Basically, I have been work as a security analyst. I don't have such knowledge about the firewall. So if you when you say these type of questions that I need answers, that's the reason I'm mute on these things. I just have a this thing you yeah I think you should add a little bit basic knowledge in it. That will be great for me, maybe for others too. That's the thing I want to mention it. Thank you.
The answer, you part of the group?
Sorry.
Are you part of the group, Danish?
Yes, I am the part of the group.
So how long have you been there?
I guess actually I was in the I guess that was Equad Paco. That was a
Yeah,
good
that one is fine. So how
mm,
long have you been in this Fortinet 48 intermediate course?
maybe I recently joined it when I got this link. Can join the FortiGate firewall
Okay, do you
group?
recall the date?
Maybe I guess around 1 month. I guess I'm not pretty sure about it. Maybe.
Okay, so had already shared the details on that group. If you check the description, every prerequisite needed for this particular course was already mentioned, and I'll try to cover the things up as well, but it might not be possible for me to go to too much basics, right? Uh,
Okay, I got it.
yeah, basics of firewall, basic routing, IP addressing and subnetting, OSI, TCP/IP, NAT, PAT, how to configure a switch. And mentioned that in the group only to make sure that you guys spend that for your time, because I
Mhm,
opened this for your chat on uh it was 12th of May, and there was a buffer of 20 days to make sure that people go through all those concepts so that
uh,
they're good
mhm,
with the prerequisites. But anyways, you still have a time because we'll be having session today and then again a week so that you guys go
mhm,
back and
mhm,
research on the things. Know what I mean?
I got it.
Yeah. All right, guys. So I guess no one is answering. So this CEO, when he's actually trying to access Facebook.com, so the first and foremost thing is his PC won't get what Facebook.com is, so
Yep.
it's going to do the DNS lookup, right? And
Yes.
as Fazan said, that is it's basically going to look for the DNS cache,
Cache.
right?
Also. Yep.
It's he's doing it for the first time, so he will check what is the DNS configured in his machine and eventually reach out to that particular DNS server and get the IP address. Now his machine knows what to reach to because now IP address is something that it can recognize and identify. Machines, everything that's taking part in the data communication, right? They only understand binary, and here we're basically talking about the IP addresses. They eventually boil down to the binary system, right? So it has the IP address now. Now CEO is going to make, this is the first thing, right?
TCP three-way handshake.
It's going to make TCP three-way handshake now, right? And after TCP three-way handshake, what's it going to do? It's going to
TLS handshake.
do SSL or TLS handshake. And after this, so TCP is second thing,
HTTP
and then the data starts flowing, right? It's going to send the HTTP get
request.
right? To retrieve the data from the facebook.com. So whatever you basically want to see on the screen, you're
Come.
basically asking for it. You're sending a get request and you get what?
The response.
You could get response. Now, here's a catch. I'm going to discuss stateful and stateless firewalls now. And it's very important that you guys understand this particular example here. See, when I'm saying that I had this packet filter over here, right? This was my packet filter. Let me make a new diagram here. It's a PC, it's connected to one of the Cisco switches, right? It has a particular packet filter here, and then traffic routes back to the ISP router and goes to the internet, right? Say for example, I have said on this packet filter that, okay, if this guy has 192.168.1.1 IP address or 1.2 IP address, it should be able to go to facebook.com. And it's a statement that I have written on this packet filter, right? So traffic flows in this direction. It's called outbound traffic.
Yes.
You call it internet bound or outbound traffic. Outbound traffic means which goes out of your network, right?
Yeah.
And a lot of people call it north south traffic.
The packet that leaves the firewall.
Correct, yeah. So you have written one statement that says 192.168.1.2 is going to go to the Facebook. So here's the thing. HTTP GET is leaving from 192.168.1.2. It's going to facebook.com, and that's allowed on this particular packet filter. So GET will work. But when the response comes from what?
Server.
Facebook, yeah, server, and it goes to the CEO's PC, right?
Right.
And again, when the traffic comes, it's going to hit the router, it gets natted, and after NAT, it gets routed to the IP filter again, packet filter again, and then it comes the Cisco and tries to go to the CEO. But if we don't have a statement here, I'm talking about the packet filters.
Mm-hmm.
We don't have a statement here that says that allow facebook.com to come to the CEO, right? It's going to drop it,
Yes.
right? So any firewall that does this is called a stateless firewall. This is a basic definition. It gets improved with time. It's stateless firewall. Now, what basically happened here? It's quite important now. See, when I say I create a statement on this particular packet filter, you know what I basically write? I write source IP, I write destination IP, I write a protocol or port. I'll say port here, and then I write action,
Yeah.
right? And then add operation happens on all these columns,
Yes.
right? If all these things are high, if all these things are matching to a particular traffic, right?
Should allow.
You allow this. You say that, okay, the answer is 1, say for this one is high, this one is also high, this one is also high, and this one is also high, then the answer will will be 1, right? If any one of these columns is not going to match, then answer will be 0, and 0 means it will drop this particular traffic. That's what actually is happening here. So here's a catch. In our case, we had this statement saying that 192.168.1.2 is being allowed to facebook.com, right? So the answer is yes, but it is not saving this context,
Stateless.
right? And when I say context, it means it is not saving the state.
Yeah. Not creating any session table or connection table.
Correct. Yeah, I will come to how it's going to basically uh, create the session, right? So it's not saving the context, it's not saving the state. And what's the state now, right? So it's very important to mention that a particular machine calculates state or context or session with the help of 5 things. There are some of the firewalls, they do it with the help of 6 things, right? You call it 5 tuple, 6 tuple,
Tuples. Yes.
right? So what are these 5 tuples? It's a
Source
bucket.
IP.
A state is a bucket, right? What I'm going to put here is I'm going to put one thing, it's called source IP. Then I put one more thing, it's called destination IP. Then I put one more thing, it's called what?
Source
Port.
port, destination port. Yeah.
Yeah, and source port, destination port is our, I'll call it source port, and this one is destination port, right? And then there is one thing, it's called protocol, right? I'm going to mix it, right? There are algorithms that basically run in your machines. You mix it and you say, let me put it in sort of a memory, right? Which is a dedicated table, which is called session table or state table or context table, right? I call it session, state, or
Connection.
context or connection table, right? You put it here, right? And then when the traffic comes back for this particular policy or anything that matches with this particular context or state, you will not do the policy lookup for that particular thing. What that actually means is this particular firewall, in our case, right? This one, which allows 192.168.1.2 to go to facebook.com, right? This particular firewall is going to get source IP, destination IP, port, action, not calculating anything, not basically creating a bucket, not doing any calculation related to the session, state, or context. It just allows it. And now when the get response comes, since it comes from Facebook, right? It's actually meant for 192.161.2. It gets dropped because this particular firewall doesn't calculate anything. It doesn't know the state, it doesn't know the context. And as long as there is not a dedicated policy, dedicated rule on this particular firewall, which will say that, okay, facebook.com should be allowed back to CEO, it won't be able to allow it, right?
Right.
So these firewalls, which do not calculate the sessions, states, contexts, or connection tables, they're called stateless firewalls,
Yeah.
right?
Right.
Now, coming to what is a stateful firewall. So any firewall that's able to calculate session, or you call it state, you call it context, or you call it connection table, it's called what? Stateful firewalls, right? Now, how do you calculate a session, state, context, or connection table or connection ID? By the way, it's the state table contains the IDs, right? You call them session IDs, state IDs, context IDs, or connection IDs. You can call them whatever you want. So stateful firewalls are basically the firewalls which will calculate the state, session, context, or connection ID of a particular traffic, right? And when it does so, it's going to keep that in a particular table, which you call a state table, you call it session table, context table, connection table, and it's going to remember it, right? For the reason that when Facebook is trying to reach back to this particular CEO's machine with a stream of data that would show up the login page on the screen, right? This is facebook.com. It goes to the CEO's PC, right? There's a packet filter in between. Packet filter says that, okay, there is someone who is trying to do what? There is someone who is facebook.com, right? It has a source port, it has a destination port, it has, now this is the source by the way. Now this is the destination IP. Destination IP in our case will be 192.168.1.1, right? And it has a protocol of 443, which is HTTPS, right? It will just mix it, generate the session ID, and look for the session ID in the state table or in the session table, and it finds one. And when it finds one, because it already had calculated the same thing, it already had calculated source port, destination IP, source IP protocol, right? Put in the table and generate the session ID. And now that it's doing the same thing for the same content, so the output will be the same, right? So it gets the same thing. It tries to look for this particular session ID in the session table or state table or whatever you want to call it. So it says that, okay, I can find the state of this particular return traffic. So I don't have to find for a policy. I don't have to find for a firewall rule for this one, right? This is the whole difference between the stateless and stateful firewalls. So stateless firewalls, they do not have the context of traffic. They don't hold the context of traffic. Stateful firewalls, they hold the context of traffic, they hold the states of traffic. And how do they calculate the states, the contexts? With the help of source, source IP, destination IP, source
And
port, destination
tuples,
port, and protocol. Yeah, you call them five tuples, right? So in today's world, we're basically dealing with the stateful firewalls, right?
right.
Every firewall which has traffic going outside to the internet, right? You need a single policy that will take you to go to that particular destination, whichever is on the internet, be it gmail.com, Facebook, or whatever it is. But when the same return traffic for that particular same session, it's not something that has been initiated on the destination end now. This is quite important, right? I was trying to do get and I was getting the response of for this, right? But the initiator was who? The
CEO.
initiator of get was the CEO, right? And based on who initiated the connection, if you have a policy for that, you will be able to match the state, right? If the Facebook generates the session from his end, right, or from its end, from the very scratch, from the very beginning, then you will definitely need a policy for that. So it's not regarding who initiated the connection, right? It is regarding what kind of file tuples are you for the policy that is actually there in your firewall, right?
Mhm.
Now, I'll ask you one question. So let's say that the CEO was also trying to access gmail.com, and I have a policy on the packet filter, right? Now, again, the get goes, you have a policy, it works, right? Now, when the response comes, do you need a policy for that on the firewall, on this particular packet filter?
Is it for me or everyone else there?
It's for everyone else, and if nobody says, then it's you, definitely.
Yeah. I guess it needs a policy.
It needs a policy, right? Because packet filter is a stateless firewall,
Yes.
right? Now, let's say that it was a stateful firewall, right? You have a policy that allows CEO to go to gmail.com. You have get. You have a policy for the get is going to work. Will response work when the Gmail sends down the response of this particular get request? Would you need a policy for that?
Oh,
Do we? Somebody just unmute, but there's a lot of noise. I was not able to hear anything. Do we need a policy for this?
no, we don't need a policy in this case.
Okay. So Now there is one more thing. So stateful firewalls, CEO was initiating the connection, right? It was sending GET. The response came. Response didn't need any firewall policy. Reason being, GET has already session ID calculated from 5 tuples, and response comes from the same contents, the same ingredients. So it will match with one of the session IDs that was put in the session table, right? It's
Hmm.
clear. Now let's say that Gmail from the scratch is trying to reach out to CEO. CEO never tried to do anything with with Gmail, right? It's the Gmail who is basically trying to make a connection with CEO. It's a stateful firewall, right? Do we need a policy for this or not? Yeah. Gmail from the very beginning is trying to reach out to the CEO.
We need a policy for that.
Correct. So we need a policy for that. So because it's doing it for the very first time, firewall is going to see it for the very first time. Unless and until you don't have a policy for this, you won't be allowed, right?
Right.
And if you have a policy for it, if for the same session you are getting any response, right? Response doesn't mean it initiated the connection from the scratch. It means it answered to what was asked, right? For example, you Gmail send get, now CO is sending response, right? It's a stateful firewall. You won't be needing a firewall policy for the return traffic. So this is the whole difference about the stateful and stateless firewalls. Now coming to the NGFW. What does NGFW mean?
Next generation firewalls.
All right. So what is an NGFW firewall? Anyone else? Come on, guys. Keep it interactive. Yeah.
I think they are both stateless and stateful firewall.
No. NGFW is always stateful firewall.
It also does IPS and IDS.
Okay.
Okay, I'll put one word. It does the deep packet inspection. That makes it more sensible, I guess, to everyone.
Okay. What else?
Uh,
It does a lot
I
of
think
things.
as it's doing in addition to that traditional firewall functions,
Hmm.
it's not just doing the deep packet inspection. There are other security features which are IPS, malware detection, and other things which are application web filtering and all those things. So it's combining all those things here, including the traditional firewall functions and this
Okay,
modern
let's
security.
calculate the traditional firewall thing. So the first thing that I got from you guys, okay, this is NGFW, right? The first one, Saran said it's stateful always, right? It's stateful firewall. It has to be stateful.
Hmm.
We're going to see why it always has to be. The stateless concept is gone now. It's depleted. We don't have any stateless firewalls now, right? If you want to maybe configure an IP table back in any of your labs, you can do that for sure, right? But there are services as well who will turn your IP tables or packet filters into stateful firewalls. And there are ways to do that, but we don't do this the packet filters now. So it's stateful firewall. NGFW is always a stateful firewall, right? It's context aware. It is session aware, state aware. Second thing was it is able to do IPS plus IDS. All right. What is the third thing? The third thing is
Application
it's able to
awareness.
do TLS
Hmm.
inspection, right?
SSL inspection.
SL.
Yeah, so it's actually SSL is not being used anymore, but you still call it SSL inspection. Otherwise, it's TLS inspection, right? But you can still call it SSL inspection. A lot of theories say that.
URL filtering it does
URL.
also.
Yeah, URL filtering,
Threat protection, and that too advanced threat protection, I would say.
advanced threat detection.
And this it controls the traffic not only based on ports or protocols, but based on applications as well. If even if they are using non-standard ports.
Application aware. Yeah. All right,
Happy
all those things.
restrictions, yeah.
Is there anything that we're missing?
L7 inspection.
L7 inspection is TLS inspection.
Okay.
Threat
What else?
intelligence.
Threat intelligence is URL filtering, advanced threat detection, application awareness, IPS, IDS.
That also.
Geo-block location.
Sandboxing, we can say. Yeah.
Sandboxing, okay, sandboxing. Yeah, someone was saying something else. Please
Geo-block
go ahead.
location.
Geo, okay,
That's
geofencing, right?
uh,
Geofencing.
that's that's a feature. Yeah. What else? What else it does? I guess this is it.
File type blocking.
File type blocking. File type blocking.
That comes
What
with your
else?
filtering.
File type blocking and URL filtering are these are two different things. So, all right, all those things. Do you guys want to add anything maybe?
Uh,
No? All
User
right.
ID. User ID.
Yeah, user ID.
Based on the user identification, it allows or denies a person. What else is there? App ID, user ID, quality of service.
Quality of QoS, quality of service.
Mm,
What else?
what else is
Content ID.
Sorry?
Content ID.
Content ID. What else?
there?
Okay, too many things, too many features that we can basically associate with this. Now, let's talk about the main differences. So, before I basically get into what is the punchline that you can basically throw or spell out to differentiate between the traditional firewalls and the NGFW, let's talk about two other types of firewalls. Because someone just said that it's able to do sandboxing, so it's quite important that I discuss a couple of more things before jumping into NGFW, right?
Mhm.
So we got two types of firewalls, or we do two types of firewalling, and it's very important, guys. One is called signature based detection or prevention, right? Other thing is called behavioral based detection or prevention. See, when I talk about the signature based detection, it means I have a device, right? It has a DB database, right? It does firewalling for sure. It's going to protect whenever anyone wants with a particular source IP wants to go to a particular destination, you say that, okay, I want to allow it, block it, right? But say, for example, if you allowed somebody, you say that 192.168.1.2, which is the CEO of the same company, he's trying to go to, this is the CEO now. I'm removing the switch now because let's keep it a little simple now. He's a CEO. He was trying to go to, uh,
Facebook.
no, let's talk about some gambling site. I'll write here gambling.
Okay.
.com. Now imagine that he has a full internet access. That's what generally people have, right? People have the complete internet access in the corporates. That means this firewall is allowing him, right?
Yes.
But when the traffic goes out of this particular firewall, right, and it comes back, so there's again get and response. Now you need a policy in just one direction, which is outbound, right? You don't need any inbound policy. Gambling.com doesn't have a policy to reach out to CEO, right? You need a single policy. Now, when the response comes, right, this particular firewall is basically going to get that traffic and check for pattern of the traffic, right? It basically tries, okay, how does this particular pattern look like? Does it look like a PDF file? Does it look like a maybe zip file, right? Does it look like maybe a WinRAR file or something like that, RAR file or something, right? So it tries to look for patterns, and these patterns are basically called signatures, right? Once it finds a signature, it finds a pattern of a particular file, it tries to look for a match in its signature database, right? It's going to basically look for that particular pattern or signature database and find a rating correspondingly, right? When it finds a rating, this DB contains a signature, say for example, it's XLMMNN, right? And your file or your traffic, your response from gambling.com got matched to this one, and your signature DB says that it's a very critical signature. It can harm your network. You go ahead and drop it, right? So I was able to calculate my decision based on comparing the traffic after calculating its pattern, after calculating its signature, and then I compared it with what I have. And what basically I have is a signature database, right?
Right.
That signature database contains a flood of signatures from the world. I'm trying for look for a match. If my signature matches with one of the signatures out there in that signature DB, and that rating corresponding to that particular signature says that it's a bad signature, you will drop it. This is your IPS and IDS. You are able to detect it. You are able to prevent your particular system from this particular intrusion, right?
Right.
Now here's a catch. Where does this DB come from? If I'm manually putting it in, there are ways of manually uploading signature DBs on the firewall, right? Then this is not an NGFW. This is important, right? This is not a next generation firewall. You can be a firewall, very good firewall, but you're not next generation firewall, right? Reason, because this signature DB has to, there's a firewall here. It has a signature DB. I'm talking about the signature based detections, signature based firewalls. It has to be in a real time connection with something which is updating this DB on scheduled basis, right? Because every day there are flood of attacks getting generated. Every day there are flood of techniques getting generated by hackers to attack the network. So generally, this particular uh, firewall or signature based firewall is connected with something which is called threat. It's a very general term, intelligence center, right? It's on cloud.
Is it like it's called in this FortiGate or general?
Threat intelligence center is a general term. In FortiGate, we call it FortiGuard distribution
Okay.
network, right? It's on cloud, and when I say it's on cloud, it means it's basically managed by the Fortinet himself or managed by this particular vendor himself, to which this NGFW belongs to, and they have this complete responsibility of finding all those attacks, finding all those corresponding signatures of all those attacks throughout the world, and send them down on scheduled basis to this
Database
particular
to it.
firewall, right? To make sure that its DB is updated. Because if it's not updated, let's take this case. You manually updated the signature DB, so it's not an NGFW firewall. Now what happens is next day a new attack comes, which was not part of the manually updated signature database. Your firewall will not be able to identify that as a threat, right?
Right.
It will treat that as a normal traffic and then you are just finish it. It becomes a nightmare for you, right? So that's the whole point of having a real time, it's a real time communication with the cloud, which is called Threat Intelligence Center, which will schedule the signature DBs, right, on this particular firewall. Generally for 48, it's 1 hour by default. After every hour, there is signature DB update
Hmm.
to make sure that no inch can be left to cause any sort of uh, unfavorable stuff, right?
Sorry to interrupt,
Be
but there are like we can also create the custom signatures, right?
Definitely we can create the ones, yeah.
Okay.
So again, there is one more thing. So when I say that it always has to be in communication with the cloud, it never means that you cannot manually upload something on this. You can definitely go ahead and upload something on this particular firewall. You can upload another manual signature DB, right? But that is not going to replace the original one, and you still need to have a real-time communication with what? With the threat intelligence center, which will always keep you updated. Now, this is regarding the threat, regarding the signature-based uh, detection, signature-based firewalls. Now, let's talk about the behavioral-based. Now, what happens in behavioral-based firewalls is it's more like sandboxing. CEO is trying to look for, maybe he's trying to stop something, right? He tries to open a site. Now, the site is actually selling alcohol as well. They're selling alcohol, right? They're selling a lot of stuff, right? Now, when he tries to access that video site, right, the response comes. The response is not present in the DB anymore. It is, although I'm in communication uh, with the cloud, right? But I feel that whatever the stuff that actually come here, it's not present in the signature DB. It's not part of the signature DB. And which are the update that I have got actually from the threat intelligence center, it's not present in that. I can configure this firewall to detect the behavior of this particular file. So what you basically do is you get this file, you get this response, you redirect to this to a particular module. It can be present within the firewall, it can be present outside your network,
Yes.
right? Or it can be present within your network as well, or it can be present on the threat intelligence center only,
Mm-hmm.
right? You get this file, send it to a device which is called sandbox, and you
Sandbox.
run it, right?
To
You
look
run
on.
it, and when you run it in an isolated environment.
Right.
Once you run it, right, you check the consequences on that particular machine on which it was run. And if there are no, what do you call it? If there are no positive flags, right? When I say positive flag, it means there was something detected.
Mm-hmm.
Virus was detected, right? Then you say that okay, it's good to go to have it back to the CEO's PC. But if there is anything fishy on this particular machine, say for example, you run it on one of the VMs, one of the machines, one of the PCs, right? In an isolated environment, by the way. And when I say isolated, it means that particular machine has no connection to anyone else, right? And if there is anything fishy, for example, if this particular file, when you run it, it started changing some of the libraries in that particular machine. It started uh, doing something with the operating system, right? With the remote access of that particular machine. Then there is something fishy, and you basically deny this file. And detecting traffic based on the behavior of a particular uh, response, traffic, or uh, file, whatever it is, it's called behavioral based detection. So these are two things: signature based detection, behavioral based detection. And whenever we're talking about these two things, we talk about them at the same time. So firewall, NGFW should be able to do what? Signature based detection.
Yes.
And no doubt you can manually sort of upload the things on that particular firewall, but on top of that, you should have the connection to the cloud, right? You should have something which is called threat intelligence center, which will schedule the updates on this particular firewall, right? That makes it NGFW. And if you talk about the behavioral base, there should be modules present in that firewall which could grab the suspicious file, send it down to the sandbox. Sandbox can be on premises, it can be on the cloud of that particular vendor, and then give you the complete disposition of that particular traffic, right? So this is the whole point where you say that when you can call a firewall as NGFW, right? So the important thing is cloud, real-time communication with the cloud, which is threat intelligence, threat intelligence center, which will
Center.
basically help you updating with all these particular signatures and features, right?
Right.
Now let me come back here. So IPS IDS is something how you basically detect all these things and prevent
Mm-hmm.
yourself from these things, right? It can be manually uploaded, it can be scheduled from the cloud. Now, TLS inspection doesn't have, I mean, you have firewalls which will be able to do the TLS inspection and they don't have to be NGFW, right? Because when you talk about the TLS inspection, it's a known MITM, man in the middle attack,
Yes.
right?
Right.
Which you basically do with the help of chain of trust of certificates. So likewise, you have URL filtering. Again, here's the thing. So talking about the URL filtering, what happens in the URL filtering is basically CEO is trying to do access abc.example.com, right? What will happen first? DNS. What will happen next? TCP.
TCP,
What
SSL,
will happen third? SSL
server,
handshake. And in the SSL handshake, there are two things: client hello,
server
which
level
contains SNI, and server hello, which contains common name or certificate.
certificates. Yeah,
Yeah,
completely.
plus cert. So what actually happens with the URL filtering is that CEO is typing this, he puts it on the firewall. The firewall is basically going to look for the SNI field for that abc.example.com, and it gets the abc.example.com, right? Sends it down to its threat intelligence center, which is on cloud, right?
Right.
Tells the threat intelligence center, tell me the rating of abc.example.com. If it's a good rating, it will be allowed. If it's not a good rating, it will be denied. It's very important,
Yes.
right? Now, there are a lot of browsers which might not support SNI. In that case, when the server hello comes, right, it's a common name which will be retrieved by this firewall and then sent down to the cloud and check for the ratings. So it's either the SNI or it's either the common name, right? Or
Yes.
anything that's actually gets from the certificate information. And the reason why it was able to do that because these both packets are not encrypted, right? It was able to see SNI, it was able to see the common name because client hello and server hello are not encrypted in the
Encrypted.
SSL handshake, right? This is important. So you get it from the client hello, you get it from common name from the server hello, right? And then you basically do this URL filtering. So URL filtering actually kicks in when the client hello basically is initiated or server hello comes. And it always will need the cloud. So that's the reason you say that NGFW is there. You can say that something is NGFW when you have real-time communication with with what? Threat intelligence center for real-time updates. All right. So that's pretty much about it. If you guys have any question, please go ahead. Else I'll see you guys next week to kickstart with the FortiGate. This was the basics, and I hope you guys are able to get it.
No one is talking here.
Yeah, no one is talking. IPsec. Okay.
Yes, it was a great session. We will see you in the next session. Thank you for the session.
All right.
Thank you,
Anyone
Vineet.
else? Hey, Nikhil. Yeah, tell me.
Probably. Thank you for the session. It was amazing.
All right, guys. Thank you so much for your time. Please take care. Have a nice week. Bye.
Can I say bye?
Bye, Samir.